Hello everyone, I'm Alfian, and today we are going to solve a tricky Hackerrank challenge called the Subarray division. And for this challenge, we are going to solve, and there are two children that share a chocolate bar from ready to run, and then each of the chocolate bar segment has an integer. And for this particular challenge, it's all about the sliding window problem, not about the chocolate itself. So this kind of challenge description trips many beginners trying to solve this Hackerrank challenge. And so without further ado, let's solve this. And we are given the s value as the array of integers, s which means the segment, and then the day is the desired value, and then the m is the length of the sliding window that we are going to solve. And then we are tasked to determine the first window to see if the first two elements equals 4 by adding them from the element 0, adding with the element 1, and then if it's to check if it's equal to 4. If it's true, then we are going to count it by 1, and we are going to declare the counter variable later. And then for this particular challenge, we also need to make an input of a number that returning a number of the counter. So let me explain this using the Excalibur drawing. Let's memorize this. I already show you the rough drawing of the array 2, 2, 1, 3, 2. 2, 1, 3, and 2. This is the array or the chocolate. And for the square shape that I draw here, it's about the m, which is the length of the window. So if I expand it like this, it's going to be the m is 3, and this one is 4, and this one is 2. So in this case, the m is 2, and then the d is the desired value. Let me type this. The m is 2, and then d is the desired value, which is 4. And then we are going to solve the first window. The first window, the 2 plus 2 is 4, and then we are going to iterate an array with the window like this, and then 2 plus 1, which is equal 3. And then since it's 4, then we are going to increase the counter by 1, and this is the counter, let counter, and this one, since we already declared the first window. And then for the second window we got 3, and then the 3 will not count the counter because it's not the desired value. And then let's iterate it again, and then 1 plus 3 is also equal to 4. Since it's 4, then we are going to count it right here by 1, increase the counter by 1. And then for the final iteration, which is 3 plus 2, with the result is 5. Since it's 5, then it's not the desired value, then we are not going to count anything. So that is why the returning value or the returning counter value is equals to 2. So And then we need to also handle the edge cases to check if the M or the sliding window width, the length of the M is higher than the length of the array. Let's use this as the example to handle the edge cases. Let's say if we have an array that is the length of the element is 1, and then we have the M value that is 2, it's already past the requirement of the challenge itself. So that is why the counter automatically returning 0, because the M value or the length of the M is invalid against the actual array that we are going to solve. And then we also need to handle another edge cases to check for if, let's say, we're going to iterate right here from the first window, from the first iteration, which is we are pointing the current iteration or as the I. Let me type the I real quick and then move it and move the I, and then we are using I as the current iteration of the window and then we're going to move them like this, and this is the current iteration. If we are using for loop and then counting again the iteration and counting again iteration, we don't want the I to go past the current iteration because the window will be out of bound. So we are going to solve it using a particular JavaScript function called the slice. So for the slice, let me give you an example. So we have the, let's say we are going to iterate the array and counting the n plus bison, and for the first argument or the first parameter of the slice function, we are going to use the current iteration, which is 0, and then for the bison, which is 2. Why is it 2? Because the bison is the second element from the array, not counting from the 0. So for the first parameter, we are counting as the 0, 1, and 2, and so on and so forth. But for the second parameter, we are using the iteration like this, starting from 1 and then 2. So that is why we are using 2. So let's say if the M value is equals 3, which is the width of the window, sliding window is 3, and then we will get the camel, we will include the camel as the subarray division. Now this is the slice function, and if we change the current iteration to 1 and then using the 3 as the second argument, which is the camel, counting the like this 1, 2, and then 3. So let's run this. We will get only the bison and camel. So we are going to leverage this function with the reduce function like this. For the first one, we are going to declare the counter value, which is the main variable to be returned later in the end. And then we can declare another constant called the length of the array, or the n in short, which is that takes the length of the array, of the segment array, and then check for the first edge case, check if the length of the window is higher than the length of the array itself. If it's true, then we are not returning anything because it's already invalid from the start. So let's declare another variable called the window sum, which is the sum of the current sliding window, that the green square that I showed you earlier from the xcolor row, using the s slice, the s array segment, and then using the slice, and then using 0. And for this particular function, we are going to calculate the first segment or the first sliding window, which is like this, as the initial value. If it's 2, width 2, and then the initial value will be 4 as the window sum, and then declare the length of the window. The length of the window is 2, so that is why the length of the window is 2, and this is 1, and this is 2, and this will be the initial value. And we are going to chain it with the reduce, because we are going to calculate the current window using the accumulator, and then current iteration, and then implicitly return the accumulator plus the current iteration, and then provide the initial value of 0. And so the initial value will be 0, and then count the accumulator, which is 2, the accumulator which is 0 as the initial value, and then plus 2, and then also plus 2 again, because we are already slicing the index 0 or the first element with the second element, which is the m value right here. So we can get the first window sum, and then we are going to check if the first window sum is strictly equal to the desired value. If it is, then we are going to add increment, or adding the counter by 1. And then for the second or the rest of the array, we can use the traditional for loop with the declaring the statement I as 0, and then as long as I is below the length of the array and minus the length of the window that we are going to iterate, and then we are going to I++, continue the iteration. So that is why the I below the current array length, the S segment array length, and the combined with the M, which is the window size, we declaring that in order to prevent the window out of bound, and then it's going to be stopped like this, and then the iteration of I will be stopped right here, because we are minding the length of the M and also the length of the array. So, and then we are going to calculate the current window sum and check if the first iteration of the window sum is equals to the window sum minus or reduced by the current segment iteration and adding with the next, like this, the next iteration, which is the I plus m. You might be asking why am I using this kind of thing as, and then using the current array iteration element and then adding the with the m. It's because for the second and to the rest of the iteration, this is the s with the I or the current iteration, and then this one is the s with the index of the current iteration plus the length of the window right here, which is 1. So that is why we get the value of 3 right here as the pointer. And then for the next iteration like this, and then also for the next iteration like this, the operation will be like that until it finishes. And then check if the window sum is also equals the desired value for the current iteration. If it is, then we are going to increment the counter by 1, and then we are going to return the counter if we finish all of the iteration. So let's run this to see if it works. Okay, so that's about it. I hope you understand my explanation. If you have any questions or if you have any better solutions, you can write in the comment section. I hope you have a great day, and I will see you on the next video. Goodbye.